I'm here to introduce the trebuchet to you. Now the trebuchet, as you can see, trebuchet, is a medieval siege weapon. So we're talking times of knights and castles. It was designed to attack the castle walls or the city walls and to knock them down. It was not designed to attack infantry, the individual people. Trebuchets were first invented actually in around 400 BC in China. But it made its way west, the technology made its way west. Eventually, Europe is where they really made it into the impressive machine it was. And it was really the aircraft carrier of its day until gunpowder was invented. And then the trebuchet kind of went away. Now, the trebuchet is made up of several parts. I'm going to talk about a few of them. You have the pouch and the sling here, and it attaches to the release pin on the top. We got the long arm and the short arm here. And in the box here, we have our counterweight bucket. Our counterweight is on the end here. In this, we've just got a bunch of coins in it. Okay? When you pull the trigger, it swings around and launches your projectile that way at our castle walls. Trebuchets were very, very large back in the day, designed again to attack castle walls, city walls. So while this is a very small version, it works the exact same way as the real ones. Now, trebuchets were not designed to be efficient. They're not trying to get the most bang for your buck, if you will. The idea of the trebuchet is it overcomes some of the physics, the limits of physics, by using sheer brute force. So an incredible amount of weight over here to launch a much smaller projectile, or a smaller amount of weight here, and that is how we get all of our energy into our castle walls. One of the main forces or main properties that we deal with when we're talking about trebuchets is leverage. Leverage is something you guys have probably all experienced. If you've ever been on a teeter-totter at a playground, which I know they don't really have them anymore, it's a shame, but teeter-totters, you got two people on each end, right? And they balance each other out back and forth. You can move one person closer or back in order to help balance that force by moving you in and around. And that's really what a trebuchet is. It's a teeter-totter. Now, we've got one long part of the teeter-totter and one short part of the teeter-totter. Now, I say the trebuchet is built backwards when thinking about leverage, and this is why. Leverage says the farther away you are from the pivot point, from our rotational point, the more force acts on your weight. So if I have 1 pound right here and 1 pound right here, they would not balance themselves out. 1 pound right here is about that distance away. So then 1, 2, 3. So this 1 pound would be 3 times farther away. So this 1 pound would equal or would act like it's 3 pounds, whereas this 1 pound would act like it's 1 pound. Now, since we get all of our power from the counterweight, we would want this to be heavier. And typically when you're throwing something, you want it to be lighter. But we've got it reversed. The projectile is going to act heavier, while the counterweight is going to act lighter. So the way we overcome that is we put an incredible amount of weight over here. So let's say the projectile is 1 pound. The rule of trebuchets is you want 100 pounds over here. So 100 to 1. That's the brute force I'm talking about. That's how much power it takes to overcome our leverage problem. Now, I say the trebuchet is built backwards. It's actually not. If leverage was our only concern, then it is. But leverage is not. There's actually a lot of physics that goes into this. However, the other one that we're going to talk about is what I call the merry-go-round effect. So a merry-go-round, again, playground. Playgrounds are great places to explore physics. The merry-go-round is the thing that spins around. Your friend gets it going super, super fast. You're standing in the middle. You're standing on the outside. You get pulled off, and sometimes you fall off, and everyone has a good laugh. Well, the merry-go-round effect is really where the trebuchet gets most of its effectiveness. Not efficiency, but effectiveness. Now, let me explain. On a merry-go-round, if you're standing near the middle, you can usually stay standing up. The centrifugal force pulling you off isn't very great at all. You're going around these fast little circles, but you're not getting pulled off. Whereas if you're standing at the edge of the merry-go-round, holding onto the bars, you're probably getting pulled off. You're holding on for dear life, possibly getting pulled off. It's good times if that happens. That's where the trebuchet gets its magic. Now let me demonstrate. So here is our person, right there, and they're in the little circle of the merry-go-round. They're near the middle. So this is the circle they are going around. Now, there's a bigger circle here. That's the person standing on the outside, or standing on the outside of the merry-go-round. This person is going to complete their circle in the same amount of time that this person is going to complete their circle. So they both spin the same number of times every minute. The difference is this person's circle is only this big. This person's circle is that big. If they both complete their circles in the same amount of time, but this circle is much, much bigger, this person must be moving much, much faster. That's how the trebuchet works. In the amount of time it takes this counterweight to go from here to here, this part of the arm, the long end, goes from here all the way up to here. That means the projectile has to be going faster. And that added speed gets it the distance and the power we need. Then when we add the sling on, as it comes around, so it comes around, now it's almost twice as far as just the arm. So now it's getting even more speed. So that added speed is what gives us the power to overcome the leverage problems and some of the other physics issues that the trebuchet has to deal with. So through brute force, it spins this fast all the way around and gets us that distance that we need to attack the castles or throw the pumpkins.